Welcome to my presentation of the project TaLPas, Task-Based Load Balancing and AutoTuning in Particle Simulations. My name is Philipp Neumann. You see my contact details in terms of my email on this slide. TaLPas has the objective to provide a solution in terms of software to fast and robust particle simulations. In particular, TaLPas focuses not only on a single particle simulation, but also on the workflow of many interdependent particle systems. This is relevant because many use cases rely on sampling of ensembles or other or bigger systems. Therefore, what TaLPas does is that it aims to develop on the one side an AutoTuning based particle simulation library called AutoTuning to leverage optimal node level performance on arbitrary architecture, sort of speaking, in particular also on heterogeneous systems such as CPUs or GPUs. Besides, we aim to develop a scalable workflow manager that can optimally distribute interdependent particle simulations, and thus this workflow manager shall also be coupled with performance prediction methods. And finally, TaLPas also aims to integrate these components together with visualization and resilience. Concerning the AutoTuning library, what we have so far is a library called AutoTuning for short-range particle systems. This one allows to select between more than 30 algorithm configurations, including data structures, particle pair traversal schemes, OpenMP parallelization, and so forth. Lately, we have particularly worked on including AutoTuning in MPI parallel simulations. What you see here on top here is a picture of a load-balanced MPI parallelized particle simulation, and the coloring indicates the algorithm configuration that has been used on this particular MPI process. In particular, what you see is, in terms of yellow, that some domains make use of the classical linked cell algorithm for particle simulations, and some others, for example the gray ones, make use of so-called Verlier lists. So sometimes one or the other traversal is faster. Besides, we are also working on AutoTuning, for example on Bayesian methods, as you can see down there. Another important aspect are particle ensembles, or the simulation of various particle simulations that depend on each other. In this scope, we currently focus on a workflow for the study of adsorption processes at the molecular scale. Therefore, we have a workflow manager that can efficiently distribute the corresponding adsorption simulations and incorporates also performance prediction methods. In particular, we incorporate the tool XtraP, which has been tuned amongst others in the scope of TaLPas developments. Here, one focus was to look at higher dimensional systems in terms of the parameters that influence performance, and here XtraP could yield an average 85% reduction in performance modeling cost lately. Finally, I want to close with an outtake of our poster on visualization aspects. Here we show and demonstrate the integration of the visualization tool Megamol into our MD code LS1Mardin. LS1Mardin also features the AutoTuning library, which is included here, and has here been extended with a Megamol integration that very efficiently enables in situ visualization on entire supercomputers. This is what you can see at the bottom left in terms of performance for static domain decompositions and also for diffusion-based load balancing systems. That's it from TaLPas side. Looking forward to our discussions and exchange in our interactive rounds.